you ever wondered why, when you step outside into the cool embrace of the night and look up at the glittering canopy above, you're not actually seeing the universe as it exists in this very moment? It is a paradox that defies our everyday human intuition, a gentle contradiction hiding in plain sight within the quiet stillness of the dark. Down here on the surface of our familiar world, we experience time as a constant, immediate flow. When you reach out to touch the rough bark of an ancient tree, or when you feel the soft tap of a raindrop on your skin, the sensation feels instantaneous. Cause and effect seem inextricably bound together in the present moment. But the cosmos does not operate by the intuitive rules of our terrestrial experience. When you tilt your head back and let your eyes wander across the vast, star-studded expanse, you are no longer living in the present. You have, quite literally, become a time traveler. This is not dramatic storytelling. It is an absolute, undeniable reality of physics, confirmed time and again by the tireless observations of modern astronomy. Let us begin this gentle journey of understanding by considering the fundamental speed limit of our universe, the ultimate cosmic constant that governs the flow of information through the endless void. Light, the very phenomenon that allows us to witness the majesty of creation, travels at a staggering velocity of almost 300,000 kilometers per second in the vacuum of space. To our human minds, this speed is virtually indistinguishable from instantaneity. If you could somehow travel at the speed of light, you could circle the equator of our planet slightly more than 7 times in a single heartbeat. Because light moves with such breathtaking swiftness across the relatively tiny distances of our everyday lives, our brains evolved to process visual information as if it were happening right now. We never had to account for the delay of light because, on the scale of a human life, the delay is essentially zero. But as we leave the comforting confines of our atmosphere and venture out into the infinite depths of the cosmos, distances expand to scales that shatter our earthly comprehension. And as the distances grow, that tiny, imperceptible delay stretches into seconds, then minutes, then years, and eventually into millions and billions of years. Every single point of light you see in the night sky is a message from the past, a phantom image of a reality that may no longer exist. The universe is a grand, silent time machine, and every time you open your eyes to the heavens, you are reading a history book written in ancient photons. Consider our closest celestial companion, the moon. When you gaze up at its pale, pockmarked face glowing in the quiet night, you are not seeing the moon as it is right now. You are seeing the moon as it was a little over 1 second ago. That is how long it took the light, reflected from the sun off the lunar surface, to cross the hundreds of thousands of kilometers of empty space to reach your retinas. This might seem like a trivial difference, a mere cosmic hiccup, but turn your attention to the sun, the roaring nuclear furnace that sustains all life on our fragile, pale blue dot. The sun sits roughly 150 million kilometers away from us. At the speed of light, it takes those life-giving photons slightly more than 8 minutes to traverse the interplanetary void and warm your skin. If the sun were to suddenly extinguish, we would not know about it immediately. For 8 long, blissfully ignorant minutes, the world would carry on, completely unaware that the source of all our warmth had vanished. We live perpetually 8 minutes in the past of our own star. But the sun and the moon are merely our closest neighbors, standing on the front porch of our cosmic home. To truly understand the vastness of the universe and the illusion of the present, we must cast our gaze out into the interstellar depths where the true scale of the mystery begins to unfold. The closest star system to our own is a triple star system, and its faintest member, a small red dwarf called Proxima Centauri, is our absolute nearest stellar neighbor. It sits roughly 4 light-years away. This means that the light leaving Proxima Centauri today will not reach our telescopes for over 4 years. When you look at that star, you are seeing it as it was over 4 years ago. You are witnessing a ghost of its past state, a memory suspended in the silence of space. This is where the contemplative beauty of astronomy truly begins to take hold. As we journey deeper into the Milky Way, the numbers become so large that they stop meaning anything to our rational minds, and instead must be felt as a sense of awe. Our home galaxy, the Milky Way, is a magnificent barred spiral, a swirling pinwheel of gas, dust, and hundreds of billions of stars. From one edge of this majestic structure to the other, our galaxy measures roughly 100,000 light-years across. Imagine the implications of this staggering fact. If you could somehow travel at the speed of light, the fastest anything can move in our universe, it would still take you 100,000 years to cross from one side of our galaxy to the other. The light arriving from the furthest edges of the Milky Way left its source before modern human civilization even existed. Let us turn our eyes even further beyond the borders of our own galaxy toward the constellation of Andromeda. On a clear, dark night, far away from the glaring lights of our cities, you might just be able to make out a faint, fuzzy smudge of light in the northern sky. That indistinct blur is the Andromeda Galaxy, our nearest large galactic neighbor. Andromeda is a massive spiral galaxy containing perhaps 1 trillion stars. But what is truly breathtaking is its distance. The Andromeda Galaxy sits approximately 2 million light-years away from us. When you look at that faint smudge with your naked eye, you are looking at the oldest light you can see without the aid of a telescope. The photons striking your retina at this very moment began their journey 2 million years ago. Early human ancestors were just beginning to walk upright when that light began quietly crossing the freezing, silent void of intergalactic space. This gentle realization that we are forever separated from the present moment of the wider universe is not a cause for despair or a reminder of our insignificance. Rather, it is an invitation to profound humility and peace. We are bound to this specific moment in time, on this specific rock, observing the universe from our unique, isolated vantage point. We are the universe observing itself. The atoms in our bodies were forged in the fiery hearts of ancient stars that lived and died before our solar system was even a cloud of dust. When we look out into the deep, we are not looking at something separate from ourselves. We are looking at our own deep history, our own origins written in the scattered light of 1 billion ancient suns. The sheer scale of this reality should bring a sense of calming stillness to our often chaotic lives. When the stresses of our daily existence threaten to overwhelm us, when our human problems feel insurmountable, we can step outside, look up and remember the vast infinite ocean of time and space in which we are suspended. The stars you see are not rushing, they are not anxious. They are burning quietly, patiently, sending their light across the incomprehensible gulfs of the cosmos, offering us a glimpse of the eternal. There is a deep, abiding comfort in knowing that we are part of something so much larger, so much older, and so much more mysterious than our everyday concerns. We find intellectual safety in this vastness, a gentle harbor where our minds can rest from the turbulent seas of modern life. But our journey is just beginning. The Milky Way and Andromeda, vast and magnificent as they are merely two small islands in a cosmic archipelago. Beyond our local group of galaxies lies the true intergalactic void, a space so empty and so incomprehensible that it challenges the very limits of human imagination. To truly understand the scale of the universe, we must leave our neighborhood and venture out into the deeper dark, where distances are measured in hundreds of millions and billions of light years. We must seek out the great monsters of the cosmos, the giant structures that rule the centers of distant galaxy clusters. And as we do, we will discover that the mystery only deepens, and the beauty only grows more profound. The deeper we look, the further back in time we travel, until we are staring at the shadows of creation itself. I invite you to quiet your mind, let go of the present moment, and prepare to step across the galactic threshold as we continue to explore the endless wonders of the silent universe together. As we drift past the familiar edges of our local galactic neighborhood, the true architecture of the cosmos begins to reveal itself in breathtaking clarity. Space is not merely a random scattering of isolated stars and lonely islands of light, as it might appear to the casual observer on a clear night. It is a vast, interconnected web, an ancient and infinite tapestry woven by the invisible hand of gravity over billions of years. Galaxies, we discover, are deeply gregarious entities. They do not prefer isolation. Rather, they gather together in the quiet dark, drawn by mutual gravitational attraction into sprawling, magnificent metropolises of light, known as galaxy clusters. These clusters are the grandest gravitationally bound structures in the universe, holding hundreds or even thousands of individual galaxies in a slow, eternal cosmic dance. The silence of these cosmic gatherings is profound, yet the gravitational forces at play within them are unimaginably powerful, shaping the destiny of every star caught within their embrace. Have you ever paused to consider what it must look like to stand at the heart of one of these majestic cosmic cities? To be surrounded not by a sky of isolated stars, but by a sky illuminated by the collective glow of entire galaxies. Let us cast our minds far beyond the Andromeda galaxy, peering deep into the darkness, specifically toward the constellation we call Virgo. There, at a distance so incredibly great that human intuition completely surrenders to the sheer mathematics of it, lies a massive congregation of galaxies known to astronomers as the Abel 2029 cluster. When astronomers point their powerful telescopes toward this specific region of the sky, they are greeted by a truly breathtaking sight. A massive collection of galaxies, all inextricably bound together by gravity, dancing gracefully around a common center. But within this swirling vortex of ancient light, one specific object commands absolute attention. Sitting right in the heart of that cluster, dominating everything around it, like a cosmic emperor resting on a silent throne, sits the largest galaxy we have ever discovered. It bears an unassuming catalog name, IC 1101. This designation comes simply from its entry number in a catalog of celestial objects created over a century ago. But do not let this clinical name deceive you for a single moment. There is absolutely nothing ordinary about this giant quietly resting in the deep cosmos. To even begin to comprehend the sheer scale of IC 1101, we must once again deliberately stretch the boundaries of our imagination. You will recall that our own magnificent Milky Way, a vast home to hundreds of billions of stars, measures roughly 100,000 light years across. That distance alone is enough to inspire profound wonder. But IC 1101 is estimated to be somewhere around 4 to 6 million light-years across. I ask you to let that impossible measurement settle into your thoughts for a moment. This single galaxy is roughly 40 to 60 times larger than our entire cosmic neighborhood. If you were to somehow gently place this titan where our Milky Way currently sits, it would not merely engulf our galaxy, it would swallow our entire cosmic neighborhood. The Andromeda Galaxy, which sits about 2.5 million light-years away from us, would suddenly find itself entirely consumed within the body of IC 1101. Even the Triangulum Galaxy, another close neighbor of ours, would be quietly absorbed into the fold. All of the dozens of smaller dwarf galaxies that orbit around us would simply become tiny, insignificant components of this giant's vast structure. But the physical span of this titan is only the beginning of the great mystery. The true staggering reality of IC 1101 lies in its population. This single galaxy is estimated to contain around 100 trillion stars. 100 trillion. To put that into perspective, our Milky Way might possess 400 billion stars at its most. This means that the giant residing in the Abell 2029 cluster has roughly 250 times more stars than our home galaxy. Imagine, if you will, the meditative task of counting. If you started counting the stars in IC 1101, uttering 1 star per second without ever stopping to rest, it would take you over 3 million years just to reach 100 trillion. And that impossible feat assumes you never slept, never ate, and never took a break. The human mind simply was not designed by evolution to hold such numbers. They spill over the edges of our comprehension, leaving us with nothing but a pure sense of awe and a profound recognition of our microscopic scale. The wonder of this cosmic monument extends far beyond its physical dimensions and its stellar population. We must return to the beautiful, haunting paradox of light and time. The delicate light that we capture today from IC 1101 left that distant galaxy over 1 billion years ago. It has been traveling continuously through the freezing, empty void of intergalactic space for more than 1 billion years, just to reach the delicate mirrors of our modern telescopes. This is a quiet, relentless journey of ancient photons across an infinite sea of darkness. When that specific light began its long, quiet trek toward us, life on our planet was still mostly composed of simple, single-celled organisms floating aimlessly in primordial oceans. Complex animals had not yet evolved to walk the earth. The great dinosaurs would not appear for another several 100 million years. Every single major event in human history, from the first civilizations raising stones toward the sky to the very invention of the telescope itself, occurred while that ancient light was still quietly crossing the vast emptiness between galaxies. When you truly realize this, the simple act of looking at the universe becomes a profoundly meditative experience. You are not just observing a distant object. You are receiving a message from a deep, forgotten past. The photons striking a camera sensor today are physical emissaries from an era when the Earth was an entirely different world, devoid of the familiar landscapes we know today. This is the ultimate lesson in cosmic humility. The universe does not rush for us. It operates on timescales so impossibly vast that a human lifetime is a fleeting thought in the cosmos. Yet, in our brief, beautiful moment of existence, we have somehow developed the capacity to understand these impossible distances. We have managed to reach out with our curious minds and touch a galaxy 1 billion light years away. This gentle pursuit of knowledge is what connects us to the infinite. It is a quiet rebellion against our own physical smallness. We are tiny, fleeting creatures bound to a fragile world, but our capacity for wonder is as boundless as the universe itself. We must pause and ask ourselves, with a sense of deep curiosity, how does a galaxy grow to become such an unfathomable monster? The universe, as we typically observe it in our local neighborhood, seems to favor the delicate, the structured, and the balanced. Spiral galaxies like our own Milky Way are graceful, rotating disks of gas and dust, actively giving birth to new generations of brilliant stars in their sweeping arms. But IC 1101 looks absolutely nothing like the Milky Way. When astronomers gaze upon it through their lenses, they do not see beautiful, sweeping spiral arms or glowing nurseries of young, hot, blue stars. Instead, they see what is known in astronomical terms as an elliptical galaxy. This means it possesses a smooth, oval-shaped appearance, a massive, featureless cloud of ancient light with no spiral arms at all. It resembles a giant, glowing golden egg softly suspended in the dark. This visual serenity, this smooth and quiet appearance, is a masterful illusion. It actively hides a history of unimaginable violence and cosmic turmoil. The journey to becoming the absolute largest known galaxy in the universe was not a peaceful, quiet evolution. As we stand on the precipice of this revelation, suspended in the contemplative silence of the cosmos, we begin to realize that every celestial body carries a secret history written in physics and light. The universe is a grand, silent library, and its galaxies are ancient volumes filled with tales of creation, destruction, and quiet endurance. The story of IC 1101 is not merely a tale of extreme size. It is a profound testament to the mechanics of the cosmos and the silent march of deep time. It challenges us to reconsider our place in a reality where such unfathomable titans can exist, silently burning through the eons while we live out our brief, hurried lives. The night sky is not a static painting, but a living theater of incomprehensible scale and endless mystery. Let us take a moment to rest here in the comforting shadow of this majestic giant. Allow the silence of the vast spaces to calm your mind and soothe your thoughts, preparing you for the awe-inspiring truth that still await us. The journey into the ancient mechanics of its creation and the terrifying forces that forged it from the primordial dark will continue to challenge everything we thought we knew about the universe. To understand the profound mystery of how such a breathtaking titan came to exist, we must journey backward through the infinite corridors of deep time. When we gaze upon the smooth, featureless glow of this magnificent elliptical galaxy, we are observing a grand illusion. It appears so peaceful, so perfectly serene, like a calm lake of ancient light resting in the dark. Yet, the science of cosmology reveals a truth that is far more complex. This galaxy did not grow to its enormous size through normal, peaceful processes alone. It became a giant through an act of cosmic violence that has been happening for billions of years. In the vast, silent theater of the universe, IC 1101 is what scientists call a cannibal galaxy. It has achieved its unimaginable scale by slowly eating other galaxies. To grasp the beauty of galactic cannibalism, you must think about how gravity works on the absolute largest scales of the cosmos. Galaxies, despite their immense size and the trillions of miles of empty space within them, do not exist in isolation. They are grouped together in sprawling, ancient clusters, held tightly together by the inescapable mutual gravitational attraction they exert upon one another. Within these massive, silent clusters, galaxies are endlessly engaged in a slow, eternal dance, moving gracefully around each other in the dark. Sometimes they pass close by one another like ships in a cosmic ocean, and sometimes they collide directly. When two of these island universes get close to each other, their combined overwhelming gravity begins to gently distort their physical shapes. Stars that have orbited peacefully for eons suddenly get pulled out of their normal, predictable orbits. Enormous, sweeping clouds of ancient gas and primordial dust get compressed and stretched across millions of light years of empty space. If the two interacting galaxies are somewhat similar in size, they might gracefully merge together over hundreds of millions of years, eventually settling into a single, larger galaxy. But if one galaxy is significantly bigger than the other, something entirely different happens in the silent depths. The larger galaxy simply absorbs the smaller one, gently but firmly stripping away its stars and its gas, and incorporating all of that scattered material into its own massive body. This slow, silent process of absorption is precisely what has been happening to IC 1101 for billions of years. Because it happens to be the largest and most massive galaxy in its cluster, it sits heavily at the very gravitational center of everything around it. It acts as a cosmic anchor, a vast basin into which everything else inevitably flows. Smaller galaxies that venture too close to this titan get trapped by its enormous, inescapable gravity. They begin to spiral inward, caught in a delicate embrace, getting torn apart and consumed over millions of years of slow collision. Each cosmic meal makes IC 1101 a little bit bigger, more massive, and more dominant. The scale of this consumption stretches our capacity for wonder. Scientists estimate that IC 1101 has undergone at least 76 major mergers over its long, ancient history. Imagine that for a moment. 76 distinct times, another substantial galaxy fell into this cosmic giant and was entirely absorbed into its glowing body. And those 76 instances account only for the major mergers. Countless smaller dwarf galaxies have also been quietly consumed over the eons. These were galaxies so incredibly small that they barely registered as a meal for this enormous predator. When you look at a classic, familiar galaxy like our own Milky Way, you are immediately struck by its beautiful, sweeping spiral pattern. Those delicate spiral arms are vibrant, active regions where stars are continuously forming, where massive clouds of cold gas are collapsing under their own immense gravity to create brilliant new stellar nurseries. Spiral galaxies possess abundant amounts of gas and dust, the essential raw materials needed for stellar birth, and they maintain a highly distinct, rotating disk shape. But IC 1101 looks absolutely nothing like this familiar, comforting structure. It is what astronomers refer to as an elliptical galaxy, which means it has a completely smooth, oval-shaped appearance with absolutely no spiral arms to be seen. Elliptical galaxies are the direct, inevitable result of spiral galaxies violently merging together. The chaotic gravitational interactions that occur during a merger completely destroy the delicate, fragile spiral structure. The overwhelming forces at play mix all the billions of stars together into a more random, spherical, or oval distribution. The fact that we observe IC 1101 as an elliptical galaxy tells us a profound and humbling story. It proves, without a shadow of a doubt, that this giant has experienced so many mergers that any original primitive spiral structure it might have possessed in the distant past has been completely and utterly erased. All of those ancient collisions, all of that immense gravitational chaos acting over billions of years, has stirred up the trillions of stars like someone carefully mixing ingredients in a vast cosmic bowl. What remains today for us to observe is this incredibly smooth, featureless giant. It stands as a majestic, silent testament to billions of years of galactic consumption. But there is something even more remarkable, and perhaps a bit melancholic, about IC 1101 that challenges our basic assumptions. Despite containing an unimaginable 100 trillion stars, it is actually a dying galaxy. This might seem like an impossible contradiction to our minds. With so many stars and such an overwhelming amount of mass, you might naturally expect this galaxy to be a vibrant hotbed of stellar activity. You might picture endless skies filled with brilliant young blue stars illuminating vibrant nebulae. But the stars within it are almost all extremely old. Most of them are what astronomers call red giants or yellow stars, which are ancient stellar objects that have already burned through most of their vital nuclear fuel. Very few new stars are currently being born inside the vast silent expanse of IC 1101. The galaxy is caught in a state of terminal twilight, slowly and inevitably exhausting the light that was gathered over billions of years of conquest and celestial accumulation. To understand this quiet tragedy, you must remember exactly how it grew so remarkably large in the first place. Every single time it consumed another galaxy, it also completely consumed that galaxy's precious gas supply. Gas is the fundamental, non-negotiable fuel required for star formation. Without vast cold clouds of gas, new stars absolutely cannot be born into the universe. Over billions of years of relentless cannibalism, IC 1101 has either used up or violently expelled most of its available gas. The mergers themselves were incredibly energetic events, often violent enough to heat the surrounding gas to extreme temperatures. This immense heat forced the gas to expand rapidly and escape the gravitational pull of the galaxy entirely. Alternatively, the massive shock waves of the collisions compressed the gas so quickly that it all formed into stars at once, in brief, intense bursts of activity. Either way, the end result is exactly the same, a galaxy that has completely run out of raw material. What remains today is a quiet giant slowly fading into the cosmic night. The stars that currently exist will continue to shine for billions of years to come. But as they slowly burn out and die, there will be no new generations to replace them. IC 1101 is like an ancient, magnificent kingdom that has successfully conquered all of its neighbors but has no children to carry on its grand legacy. It is massive, powerful, and utterly magnificent. But it is also steadily approaching the end of its active life. It gently teaches us that even the most colossal structures in the universe are bound by the inescapable laws of time. It invites us to find peace in our fleeting existence, knowing that even a galaxy of 100 trillion stars must eventually yield to the deep silence of the infinite. As we journey deeper into the heart of this fading cosmic giant, moving past trillions of ancient, slowly cooling stars, we approach a region of space that challenges our very understanding of reality. At the absolute gravitational center of IC 1101 lies something even more incredible, and perhaps more terrifying, than the enormous galaxy itself. Sitting in silent dominion at the core of this cosmic behemoth is one of the largest known supermassive black holes in the entire universe. It is a fundamental truth of modern astrophysics that almost every large galaxy harbors a supermassive black hole at its core. Our own beloved Milky Way possesses one, a cosmic entity known as Sagittarius, a star, which contains roughly 4 million times the mass of our Sun. The black hole waiting at the center of the Andromeda Galaxy is considerably larger, containing somewhere between 100 million and 200 million solar masses. But the black hole reigning at the center of IC 1101 exists in a completely different, almost incomprehensible category of existence. Scientists estimate that it contains somewhere between 40 billion and 100 billion times the mass of our Sun. Let us pause and try to gently guide our minds around the sheer weight of that number. To put that staggering figure in perspective, this single black hole might possess 25,000 times more mass than the black hole located at the center of our entire Milky Way galaxy. If you could somehow manage to weigh the Earth, you would find it has a mass of about 6 trillion kilograms. That sounds like a monumental amount of matter until you carefully compare it to our Sun, which is roughly 330,000 times more massive than the Earth. Our Sun is a perfectly ordinary, average star, neither particularly massive nor particularly diminutive by standard stellar measures. Now, I ask you to take the entire mass of our Sun and multiply it by 50 billion. That resulting, unimaginable figure is roughly how much mass is densely packed into the supermassive black hole at the center of IC 1101. All of that incomprehensible mass is perfectly compressed into a single region of space from which absolutely nothing, not even a single photon of light, can ever hope to escape. The boundary of a black hole, the absolute point of no return, is known to physicists as the event horizon. The gravitational pull at this invisible threshold is so immensely intense that space and time themselves bend and fold, trapping light forever in a silent, inescapable grip. The physical size of a black hole's event horizon depends entirely upon its mass. For a monster containing 50 billion solar masses, the event horizon would possess a radius of roughly 150 billion kilometers. That number might simply sound like another large figure, but we must ground it in a reality we can attempt to visualize. Our entire solar system, stretching from the warm surface of the Sun all the way out to the freezing, distant orbit of Neptune, measures about 9 billion kilometers across. The dark event horizon of IC 1101's black hole is roughly 16 times larger than our entire solar system. If you were to somehow place this monstrous black hole right where our Sun currently sits, its dark, silent boundary would extend well beyond the distant orbit of Pluto, completely and instantly engulfing everything we consider to be our cosmic home, plunging our entire reality into eternal darkness. What would it actually be like to travel near the edge of this monstrous silent anomaly? The fundamental physics governing such extreme, hostile environments are completely bizarre and violently counterintuitive to our everyday human experience. Time itself, which we feel as a constant, steady river, would actually pass differently near the event horizon compared to a safe distance far away. If you were to watch someone falling toward the black hole, you would see their movements slowly stretch and appear to freeze completely as they approach the horizon, while they would never seem to actually cross the boundary from your perspective. Inside that dark event horizon, all physical directions lead inevitably toward the singularity at the center. Space and time themselves become so drastically warped that the very concept of escaping becomes physically and mathematically meaningless. The singularity, a point of theoretically infinite density hidden at the core, would mercilessly tear apart anything that fell in, stretching matter into long, thin, subatomic strands through a violent process physicists have colorfully nicknamed spaghettification. Yet, here is where the story takes a gentle, unexpected turn toward the serene. Despite its enormous size, its terrifying mass, and its reality-bending properties, the supermassive black hole at the center of IC 1101 is currently relatively quiet. It is not actively devouring huge, turbulent amounts of stellar matter. There is no brilliant, blinding accretion disk of superheated gas swirling violently around it. There is no powerful, searing jet of raw radiation shooting out into deep space at nearly the speed of light. The black hole is simply there, waiting in the dark, but it has already consumed almost all of the material that was easily within its immediate gravitational reach. This profound quietness is directly related to the very same phenomenon that has permanently stopped IC 1101 from forming new young stars. Most of the free gas in the galaxy has already been exhausted or expelled, and without a steady stream of gas falling toward the center, the black hole has virtually nothing left to eat. Occasionally, a wandering star strays too close and gets violently torn apart, providing a brief, fleeting meal. But these dramatic events are exceedingly rare. The black hole, much like the fading galaxy that faithfully hosts it, is a sleeping giant in repose, possessing unimaginable power, but remaining largely dormant in the cosmic night. There are, however, still faint, ghostly traces of the black hole's active, violent past. When astronomers point their instruments toward the core, they have detected a distinct radio source catalogued as PKS 508 plus 059. This faint radio emission originates from relativistic jets, which are immense streams of particles accelerated to nearly the speed of light and violently ejected from the chaotic vicinity of the black hole. These ancient jets are directly powered by the black hole's immense rotation and its twisting magnetic fields, and they possess the raw energy to carve out enormous empty cavities in the surrounding superheated gas. Images captured by advanced X-ray telescopes show these vast cavities clearly. They are essentially colossal bubbles of very hot, very thin gas that have been blown outward by the staggering energy released near the black hole in ancient times. Some of these silent bubbles are millions of light years across, serving as a permanent, glowing testimony to chaotic periods in the deep past when the black hole was vastly more active than it is today. The sheer energy required to inflate these massive bubbles is staggering, roughly equivalent to the total combined energy output of billions of stars shining constantly over millions of years. This complex, ongoing relationship between supermassive black holes and their host galaxies is one of the most fascinating and active areas of research in modern astrophysics. Scientists now believe, with growing certainty, that supermassive black holes play a profoundly crucial role in regulating the growth and long-term evolution of galaxies. When large amounts of gas flow toward a galaxy's center, the active black hole can release enough furious energy to heat that gas and forcefully push it outward, effectively preventing it from ever cooling and collapsing to form new stars. This creates a kind of cosmic thermostat effect that actively helps determine the final size, shape, and properties of galaxies across the universe. In the specific case of IC 1101, this immense feedback mechanism may be largely responsible for the galaxy's current fading state. The black hole has actively helped shut down star formation by heating the remaining gas and preventing it from cooling. The giant galaxy and its giant black hole have slowly reached a kind of eternal, silent equilibrium, with each one having powerfully shaped the other over billions of years of shared, intertwined evolution. Let us delve deeper into the ancient mechanics of how this particular monster grew to such incomprehensible proportions. Black holes do not simply swell in isolation, they grow by consuming the matter that relentlessly falls into them. When entire galaxies collide and merge, the supermassive black holes hiding at their respective centers eventually find each other and merge as well. Over the course of IC 1101's long, violent history of galactic cannibalism, its central black hole has been fed again and again. Every single galaxy that IC 1101 consumed over the eons added the mass of its own central black hole to this continuously growing monster. Every major merger brought in more raw fuel for the black hole's seemingly insatiable appetite, steadily increasing its dark mass and expanding the reach of its terrifying event horizon. The intricate process by which two supermassive black holes finally merge is simultaneously one of the most fascinating and violently energetic events in the entire universe. When two galaxies initially collide, their central black holes do not immediately find each other in the vastness of the new, chaotic system. They are separated by vast distances and surrounded by the swirling gravity of billions of individual stars. But as the cosmic merger progresses over hundreds of millions of years, a phenomenon known as gravitational friction with the surrounding sea of stars gradually causes the two black holes to slowly spiral toward the absolute center of the newly combined galaxy. Eventually, the two dark titans get close enough to form a binary system, locking into a deadly, inescapable orbit around each other. As they circle one another, they constantly lose energy through the emission of gravitational waves, which are actual physical ripples traveling through the very fabric of space-time itself, carrying the silent echo of a dark collision across the infinite depths of time. These invisible ripples, these gravitational waves, carry immense amounts of energy away from the massive binary system, causing their deadly orbit to gradually shrink over millions of years. The two dark titans spiral closer and closer together, orbiting faster and faster through the ancient dark, until finally they merge completely in a catastrophic cosmic event that releases truly enormous amounts of energy into the surrounding void. When two supermassive black holes finally merge, the gravitational waves they produce are among the most unimaginably powerful events in the entire universe. This final, silent merger releases more raw energy in a fraction of a second than all the billions of stars in a typical galaxy combined, though almost all of this staggering energy is released in the form of invisible gravitational waves rather than visible light. These waves ripple outward at the absolute speed of light, literally stretching and squeezing the very fabric of space itself as they pass through the cosmos, like silent, invisible tsunamis of pure gravitational energy. For most of our history, humanity was completely deaf to this cosmic symphony. We could only look at the universe using light, blind to the physical vibrations of space-time. It is only in our very recent history that we have carefully developed the technology required to detect these impossibly faint gravitational waves. The very first direct detection of this phenomenon came in the year 2015, when the highly sensitive observatories measured the faint ripples from two stellar mass black holes merging about 1 billion light-years away from our planet. Since that monumental breakthrough, dozens of these incredible gravitational wave events have been successfully observed by scientists, opening up an entirely new, deeply profound way of studying the hidden universe. We are no longer just looking at the cosmos. We are finally listening to it. And future gravitational wave detectors, like the planned Laser Interferometer Space Antenna mission that is scheduled to fly in the quiet vacuum of space, will be specifically designed to detect the much deeper, lower-frequency mergers of supermassive black holes. When this incredible mission launches, perhaps sometime in the decade of the 2030s, it might actually possess the capability to detect cosmic events remarkably similar to the ancient, violent mergers that slowly built up the central black hole of IC 1101. We will be able to sit in the quiet of our world and literally listen to the universe as giant black holes collide and merge in the deep dark, adding another profound sense to our growing astronomical toolkit. The central black hole of IC 1101 has experienced dozens upon dozens of such monstrous mergers over its long, complex history. Each violent merger added incredible mass and profoundly altered the black hole's fundamental spin. But the chaotic process of multiple sequential mergers also dramatically affected the surrounding host galaxy, as the wildly orbiting, merging black holes violently flung ancient stars outward through intense gravitational interactions. This relentless gravitational scouring is precisely why the core of IC 1101 is so inexplicably large, yet simultaneously relatively faint compared to its immense size. Repeated black hole mergers have systematically scattered billions of stars away from the very center of the galaxy, creating a core profile that is highly unusual for galaxies of this staggering size. When astronomers conducted a detailed study in the year 2017, using incredibly sharp images captured by the Hubble Space Telescope, they carefully measured this galactic core and made a truly shocking discovery. They found that the central core alone stretches across nearly 14,000 light-years of space. That means just the central core of IC 1101, not the entire galaxy, but merely its innermost central region, is physically larger than most entire dwarf galaxies found throughout the universe. This core alone contains more stars than the vast majority of independent galaxies currently in existence. The event horizon of a black hole, which is the terrifying boundary beyond which absolutely nothing can ever hope to escape, naturally gets larger as the black hole continuously gains mass. For a black hole containing 50 billion solar masses, the event horizon would extend outward for about 150 billion kilometers. That is roughly the entire distance from our warm sun to the freezing, absolute outer reaches of our solar system, all perfectly contained within a single region of space, where not even a single photon of light can ever escape. Around this supermassive black hole, there is a bright radio source that dedicated astronomers have carefully cataloged as PKS 158 plus 059. This specific radio emission comes directly from massive jets of material being violently blasted outward from the immediate vicinity of the black hole at nearly the speed of light, even though the black hole is not nearly as active as it once was in the ancient past. It still occasionally flares to life, violently releasing enormous, unimaginable amounts of raw energy into the surrounding, silent space. Now, I want to invite you to take a deeply contemplative journey with me to help you truly, emotionally appreciate the impossible scale of what we are talking about. Imagine, if you will, that you could somehow magically travel from one absolute end of IC 1101 to the other. To make this epic journey, you would need to cross a distance of somewhere between 4 million and 6 million light years. Remember, light travels at a staggering speed of roughly 6 trillion miles per year, moving faster than anything else in physical reality. Even at that incomprehensible, mind-bending speed, simply crossing the width of IC 1101 would still take you millions upon millions of years. But let us try another, more grounded comparison to truly humble our human perspective. Consider the Voyager 1 spacecraft, proudly launched by humanity in the year 1977. It is currently the absolute fastest human-made object ever to leave the comforting embrace of our solar system. It is quietly traveling through the cold interstellar void at a speed of about 38,000 miles per hour relative to our Sun. At that incredible speed, which is vastly faster than a speeding bullet, Voyager 1 would still take roughly 80,000 years just to reach the absolute nearest star to our solar system, Proxima Centauri, which sits only about 4 light-years away from our planet. If you wanted to use Voyager 1 to cross the entire width of our Milky Way galaxy, it would take you roughly 2 billion years of silent, endless travel. And to cross the unimaginably vast expanse of IC 1101 at that exact same speed, you would need to wait somewhere between 80 billion and 120 billion years. I want you to let the weight of that number gently settle into your mind. That is significantly more time than our entire universe has even existed. The universe itself is only about 13,800,000,000 years old. Even if you had started your journey in our fastest spacecraft at the very moment of the Big Bang, you would not even be a fraction of the way across this single, solitary galaxy. Crossing this cosmic giant using human technology is not just difficult, it is completely and utterly impossible. Here is yet another gentle way to think about this staggering scale, a simple visualization that brings the infinite down to the intimate. If you could somehow magically shrink our entire magnificent Milky Way galaxy down to the manageable size of a standard dinner plate, perhaps measuring about 10 inches across, then IC 1101 would be roughly the size of a very large Olympic-sized swimming pool. Our entire galaxy, containing all of its hundreds of billions of stars, the beautiful sweeping spiral arms, the glowing nebulas, and the tiny, fragile planet where we make our home and live out our entire lives, would be nothing more than a tiny, fragile dish floating completely lost in a vast, overwhelming sea. This is the true, humbling scale of the cosmos. Or consider this profound realization about light and time. The ancient light arriving from IC 1101 has been traveling toward our world for over 1 billion years. In all of that immense time, light has been continuously streaming away from this giant galaxy in absolutely every possible direction, filling the void with its silent glow. Every single second of every single day, IC 1101 radiates enough light to travel about 186,000 miles into the dark. Over a period of 1 billion years, that light has traveled a distance of 1 billion light years, which is roughly equivalent to 6 billion trillion miles of empty space. And it is only now, at this very moment in cosmic history, just arriving at the delicate glass mirrors of our waiting telescopes. These are truly ancient photons that initially left their distant home galaxy when the Earth was still merely in its early primitive stages of developing complex life. The photons striking a camera sensor tonight are physical artifacts from a time before humanity, before the dinosaurs, before almost everything we consider to be ancient history on our world. The universe is speaking to us in a slow, patient whisper, reminding us that we are just temporary, fleeting observers in an eternal, magnificent theater of light and gravity. As we stand in the quiet awe of these ancient photons finally reaching our world, we must take a deliberate moment to reflect upon the remarkable, fragile ingenuity that allows us to witness such distant wonders. It is wonderfully easy to forget, when we speak so casually, about a giant galaxy floating over 1 billion light-years away, just how profoundly challenging it is to learn anything at all about the deep universe. The fact that we comprehend the immense scale, the staggering mass, and the violent history of IC 1101 is a beautiful testament to centuries of relentless human curiosity and quiet dedication. The story of how we gently pull these cosmic secrets from the dark begins with a slow, deliberate evolution of our instruments of vision. Our mechanical eyes raised hopefully toward the infinite mystery. When the pioneering astronomer Galileo first lifted a primitive, narrow tube of glass toward the night sky in the year 1609, human perception was forever changed. He could suddenly see the rugged, ancient craters scattered across the pale face of our moon, and he could watch the small, quiet moons of Jupiter engaged in their eternal clockwork dance. But the true, deep universe, the realm of distant galaxies, remained completely invisible to him. They were simply too faint, their ancient light too incredibly delicate to be gathered by the small, simple lenses of those early days. For over 300 years, our collective vision slowly improved as our telescopes grew larger, heavier, and more sophisticated. By the time the dedicated observer William Herschel first spotted the faint, fuzzy smudge of IC 1101 in the year 1790, he was looking through a carefully polished mirror roughly 18 inches across, which was considered an absolute marvel of his era. Yet, even with that grand instrument gathering the starlight, he had absolutely no way of knowing what he was truly looking at. The technology did not exist to measure how far away this object was, and the scientific understanding did not exist to recognize that it was an entire galaxy separate from our own. The mystery remained securely locked away in the profound silence of space. For a very long time, humanity faced an insurmountable, invisible wall in our quest to see the cosmos clearly. That wall is our own atmosphere, the blanket of air that sustains our fragile lives, that gives us the gentle winds and the soft, blue skies, is simultaneously a major obstacle for those who wish to read the stars. The Earth's atmosphere is constantly moving, shimmering, and breathing with thermal currents. This restless, invisible motion is exactly what causes the stars to beautifully twinkle in our night sky. But for a dedicated astronomer seeking the truth of the void, that romantic twinkling is a severe distortion, a frustrating blur that smears the delicate, ancient light, arriving from the furthest reaches of the dark. For most of the 20th century, astronomers could see that IC 1101 existed in the void, and they suspected it was remarkably large, but they could not pierce the atmospheric veil to study its intricate structure. Everything changed in a profound, revolutionary way with the launch of the Hubble Space Telescope in the year 1990. By placing an observatory high above the turbulent, shifting atmosphere, floating in the absolute silence and perfect calm of the vacuum. We were finally able to open our eyes fully to the universe. Over the quiet decades since it was placed in orbit, Hubble has stared deeply into the heart of IC 1101 multiple times. It was Hubble's unblinking crystal-clear vision that revealed the staggering details of the galaxy's unusually depleted core, its vast glowing halo of ancient stars, and its complex gravitational relationship to the other members of its sprawling cluster. The images returned from the silence of orbit allowed us to witness the true magnitude of this cosmic giant. But optical light, the kind our human eyes have evolved to see, is only one tiny fraction of the cosmic symphony. To truly understand a monster of this magnitude, we had to learn to listen to the universe in invisible colors. Modern astronomers have gently turned a variety of specialized instruments toward this region of the sky, capturing wavelengths of light that completely transcend our biological limits. Giant radio telescopes, resting in quiet valleys on Earth, have carefully detected the faint, low-frequency emissions from the dormant, supermassive black hole at the center. Powerful X-ray observatories, orbiting high above our world, have mapped the superheated, invisible gas that fills the immense spaces between the galaxies in the cluster. Infrared telescopes have peered straight through the obscuring veils of cosmic dust to study the oldest, coolest stellar populations dwelling within the giant's elliptical body. Each new observation, each different frequency of light gathered from the dark, slowly adds another crucial piece to the puzzle, deepening our sense of wonder. We are continuing to push the boundaries of this gentle exploration. Ground-based telescopes have improved dramatically using a brilliant technique called adaptive optics, which employs lasers and deformable mirrors to correct for the atmospheric blur in real time, steadying the image of the cosmos. And even more powerful instruments are joining the journey. The James Webb Space Telescope, launched in late 2021, has already begun observing distant galaxies with unprecedented sensitivity in the infrared spectrum. Meanwhile, the extremely large telescope, currently under construction in the high, dry mountains of Chile, will possess a staggering main mirror, nearly 130 feet across, when it opens its eye to the sky in the late 2020s. These towering achievements of human cooperation will allow us to study the silent universe with a clarity that previous generations could only dream of. Yet, even with all these marvelous technological extensions of our senses, there remains one fundamental, staggering challenge. How do we actually measure the distance to something that is so unfathomably far away? Distance is arguably the most crucial measurement in all of astronomy, but you cannot simply stretch a measuring tape across the infinite void. For relatively nearby stars, astronomers use a beautiful geometric technique called parallax, measuring how a star appears to gently shift against the distant background as the Earth traces its yearly orbit around the Sun. But IC 1101 is far, far too distant for this method. The shift is so impossibly microscopic that it completely vanishes into the noise of the cosmos. To bridge these terrifying cosmic gulfs, we must rely on a sequence of brilliant deductions known as the cosmic distance ladder. Astronomers look for specific, recognizable beacons of light, called standard candles. One of the most important of these is a devastatingly violent event called a Type 1 supernova. These occur when a specific type of dead star, a white dwarf, accumulates too much stolen matter from a companion star and detonates in a thermonuclear explosion of absolute, uniform brightness. Because we understand the precise physics of these explosions, we know exactly how bright they should truly be. By measuring how faint they appear to our telescopes, we can confidently calculate how far the light had to travel to reach us. But for the absolute deepest reaches of the universe, we rely on the very fabric of space itself. As our universe continuously expands, it physically stretches the ancient light traveling through it. This relentless stretching pulls the light waves toward the red end of the electromagnetic spectrum, a beautiful phenomenon we call redshift. The further away a galaxy is, the more the expanding universe has stretched its light by the time it reaches our fragile world. By carefully measuring the redshift of the light arriving from IC 1101, scientists determined that this giant sits roughly 1.04 billion light-years away from us. Every single measurement requires a profound chain of logic, a testament to the quiet power of human reason, reaching out into the unknown mystery. This realization brings us to one of the most philosophically profound and deeply meditative truths in all of science. When we look at IC 1101, we are not seeing it as it exists today. We are looking directly into the deep, unreachable past. We are seeing it exactly as it was over 1 billion years ago, when the light we detect today first began its silent journey toward Earth. In a very real, physical sense, all astronomers are cosmic archaeologists, gently brushing away the dust of time to study the history of the universe. When the light we captured tonight first began its journey, the Earth was an entirely different world, devoid of complex animals, a quiet alien sphere slowly drifting around a younger sun. We have absolutely no way of knowing what IC 1101 looks like at this very moment. Over 1 billion years, stars have burned out, new mergers may have occurred, and the central black hole might have awakened. The present state of that distant giant is a secret hidden behind a billion-year wall of time, and that information will not arrive here until another 1 billion years have slowly passed. This time delay is both a profound limitation and an extraordinary opportunity. It naturally limits our ability to understand the current, present state of the universe, leaving us forever disconnected from the exact present moment of the distant cosmos. But simultaneously, it allows us to study cosmic history directly by looking at galaxies at different distances, and therefore at different points in the ancient past. Astronomers can actually piece together how galaxies have changed over cosmic time. We can gently peer into the era when the universe was young, compare those primitive structures to more recent examples, and lovingly trace the evolution of cosmic structures over billions of years. IC 1101, seen exactly as it was 1 billion years ago, provides a spectacular snapshot of a giant galaxy in a very particular stage of its evolution. By combining this single, magnificent snapshot with countless others captured from different depths of the void, astronomers slowly build up a comprehensive picture of how such titans form and change over the vast eons of time. It is a humbling reminder that our knowledge, while vast, is forever bound by the gentle, unyielding limits of light and time. The sheer numbers we have been discussing throughout this quiet journey are so staggeringly immense that they naturally become entirely abstract to our terrestrial minds. We are speaking of 100 trillion stars, distances spanning 4 million to 6 million light years, and time periods measured in billions of years. These are numbers our biological brains, shaped by the gentle rhythms of a small planet, evolved to handle quite poorly. We are beautifully adapted for counting small, intimate groups, for measuring distances we can comfortably walk, and for tracking time spans limited to passing seasons and human generations. Absolutely nothing in our long evolutionary history prepared us to easily comprehend the true cosmic scale. So, let us gently engage in contemplative thought experiments, an exercise in imagination designed to help make these unfathomable numbers feel more present in our consciousness. Imagine, for a quiet moment, that you passionately wanted to take a single photograph of every individual star residing within the vast embrace of IC 1101. Suppose you possess a miraculously fast camera that can flawlessly snap exactly one picture every single second, and you are endowed with endless endurance, never needing to pause or rest. How long would it actually take you to photograph all 100 trillion stars? The mathematical answer is deeply humbling. It would take over 3 million years of continuous, uninterrupted photography. If you had begun taking these pictures when the very first early humans evolved and began walking upright across the ancient savannas of Earth, you would still have millions of years of relentless photography stretching endlessly ahead of you today. Or consider this profound comparison regarding the sheer abundance of matter in this giant. The tiny individual grains of sand scattered across all the sweeping beaches and vast deserts of Earth number perhaps in the hundreds of trillions. This single distant galaxy, IC 1101, contains roughly as many massive burning stars as there are tiny grains of sand on our entire beautiful planet. Each one of those distant stars is a roaring nuclear furnace, patiently burning primordial hydrogen into heavier elements, releasing warm energy that streams outward in absolutely every direction into the cold void. Each one holds a unique story, an ancient history, and a silent, unfolding future. Now, let us attempt to imagine the impossible feat of physically walking across this majestic structure. The average human walking speed is a gentle, steady pace of about 3 miles per hour. At that deliberate, unhurried pace, if you were miraculously walking 24 hours a day without ever stopping to sleep or rest, it would take you a staggering 50 trillion years to walk from one distant edge of IC 1101 to the opposite side. I invite you to sit with that number for a moment. That is over 3,000 times longer than the current known age of the entire universe. You could walk patiently for the entire history of absolutely everything that has ever happened, from the fiery birth of the Big Bang right up until this very present moment, and you would have covered less than 1/13,000th of the total distance across this single, solitary cosmic island. Or think about the profound isolation imposed by these immense scales, even upon the fastest phenomenon we know, the flow of communication. Light is the absolute fastest thing in our universe, traveling gracefully at about 670 million miles per hour. A simple message transmitted via a pulse of light from one far side of IC 1101 would take anywhere from 4 million to 6 million years just to cross the vast gulf of stars and reach the other side. If an advanced civilization residing on one outer edge of this giant galaxy decided to send a greeting to another civilization located on the opposite edge, the receiving civilization would not even get the initial message for millions of years, and any hopeful reply would take millions of years more to make the return journey. These quiet thought experiments do not magically make the massive numbers truly, fundamentally graspable. Perhaps nothing truly can. The human mind simply is not architecturally built to naturally hold such immense cosmic scales, but they can gently give us a deep, intuitive sense of the vastness, a profound feeling of awe in our gut, even if not a perfect, mathematical understanding in our heads. This contemplation naturally leads us to gently turn toward a profound question that might currently be lingering in your quiet mind. If I see 1101 is truly so enormous, so impossibly vast and filled with light, are there perhaps other beings, other curious minds, living out their lives there? Could a giant galaxy that contains 100 trillion burning stars be a sprawling home to intelligent life? This is, of course, the kind of profound existential question that our current science simply cannot answer directly right now. We possess absolutely no way of detecting biological life in distant galaxies floating a billion light years away. We currently barely have the technological capacity to look for simple life hiding in the shadows of our own local solar system, let alone across such unimaginable interstellar voids. But we can quietly meditate upon what the sheer probability of these numbers suggests to us. If life fundamentally requires stable planets to take root, and planets naturally orbit around stable stars, then a galaxy graced with significantly more stars should logically offer significantly more potential, welcoming homes for life to flourish. Our own Milky Way galaxy might harbor somewhere between 100 billion and 400 billion planets in its swirling embrace. If even a vanishingly tiny fraction of those distant planets possess the exact, delicate conditions suitable for life, there could currently be millions of vibrant worlds teeming with living things hidden in our galaxy alone. Now, let us gently scale that breathtaking probability up to the titanic dimensions of IC 1101, with its astonishing population of 100 trillion ancient stars. This single galaxy could easily harbor hundreds of trillions of orbiting planets. Even if only 1 in a billion of those distant planets successfully developed the delicate spark of life, that incredibly pessimistic fraction would still result in hundreds of thousands of living worlds scattered throughout its vast interior. Even if only 1 in a trillion of those worlds somehow managed to develop intelligent life capable of building complex civilizations and pondering the dark, that would still mean there could be 100 distinct, thinking civilizations quietly residing within IC 1101. Of course, these staggering numbers are ultimately based on assumptions that we currently cannot verify. We honestly do not know how common the spark of life is in the wider universe. We do not know how often simple life successfully evolves the rare gift of high intelligence. We do not even know for certain that life universally requires rocky planets like ours, or that it demands liquid water, or that it must be inherently based on carbon chemistry. The sheer, staggering diversity of physical conditions in the universe might be beautifully matched by an equal diversity of strange, unimaginable forms that life can take. What we can confidently say, with a deep sense of wonder, is that IC 1101 offers an absolutely enormous, ancient canvas for whatever mysterious processes might lead to life. A galaxy of that incomprehensible size has been quietly producing massive stars for billions of years. Heavy, complex elements, the essential carbon, oxygen, and iron that all living things fundamentally need, have been tirelessly manufactured deep within stellar cores and violently scattered through space by supernovas countless times over the eons. Whatever the ultimate cosmic recipe for life might truly be, this giant has possessed vast resources and enormous oceans of time to patiently cook it up. And if intelligent life does indeed exist deep within IC 1101, what might they feel when they look up at their own night sky? Their view of the cosmos would be profoundly different from ours. When we look up from Earth, we see a relatively sparse field of individual stars with the faint band of our galactic disk stretching across the heavens. But observers in that distant giant would see stars absolutely everywhere, shining brightly in absolutely every conceivable direction. The physical density of stars packed into an elliptical galaxy like IC 1101 is significantly higher than in the flat disk of a spiral galaxy like ours. If a world were located near the dense center, their local night sky would be absolutely ablaze with perpetual light. The ancient stars would crowd so closely together in the heavens that there might not be any true, deep darkness at all. The glow of billions upon billions of nearby stars would gently fill their sky with a perpetual golden twilight. Navigation by individual stars would be essentially impossible because there would simply be too many brilliant points of light to distinguish one from another in the overwhelming brightness. Further out from the dense, beating heart of the galaxy, the conditions might be somewhat more akin to what we experience on Earth, but still profoundly different. No beautiful, sweeping, spiral arms would trace familiar, comforting patterns across their heavens. No glowing, central band of light would mark the flat plane of a galactic disk like our Milky Way. Instead, the ancient stars would be distributed in a much more uniform, spherical pattern, completely surrounding any curious observer in a vast, glowing shell of stellar light. Would such hypothetical beings know about the violent, chaotic history of their massive home? Would they have discovered through quiet observation that their majestic galaxy was built piece by piece from the shattered remains of dozens of smaller galaxies, consumed over billions of years of cosmic time? Would they have cleverly detected the enormous, sleeping black hole lurking at their galaxy's absolute center? Or mathematically figured out that their cosmos was billions of years old? We cannot possibly know the answers to these quiet mysteries. But it is a deeply fascinating, humbling thought to consider that somewhere in the vastness of IC 1101, on one of hundreds of trillions of possible planets, intelligent beings might be looking up and asking the exact same existential questions about the universe that we ask here on Earth. They might be looking out at the surrounding silent space, seeing other distant galaxy clusters in the deep dark, and wondering if those faint, distant smudges of light contain other searching minds. They might have even detected our own Milky Way galaxy, though from their unimaginably distant perspective, our magnificent home would appear as just another tiny, unremarkable spiral galaxy floating among billions of others. The universe is vast beyond all human comprehension, and the quiet possibilities it contains are equally vast. Now, I want to take a gentle, deliberate moment to explore more about the invisible environment that completely surrounds C 1101, because no galaxy, no matter how impossibly large, exists in complete and total isolation from the rest of the cosmos. As we have learned on this quiet journey, IC 1101 sits grandly at the very heart of the Abel 2029 galaxy cluster, and truly understanding the mechanics of this ancient cluster helps us deeply understand why this specific galaxy became so enormous in the first place. Galaxy clusters are some of the absolute largest gravitationally bound structures in the entire universe. They can contain hundreds, or sometimes even thousands of individual galaxies, all locked together in a slow, eternal dance, orbiting gracefully around a common, invisible center of mass. The immense space existing between the individual galaxies in a cluster is not simply empty, silent void. It is actually filled with an incredibly tenuous, extremely hot gas, which has been heated to unimaginable temperatures of tens of millions of degrees by the staggering gravitational energy released as the massive clusters slowly formed over billions of years. The Abell 2029 cluster is what astronomers specifically call a relaxed cluster, which means it has peacefully settled into a fairly stable, balanced configuration over billions of years of cosmic time. The countless galaxies dwelling within its gravitational embrace have had ample time to slowly sort themselves out, with the most massive, heavy objects gradually sinking toward the absolute center due to a fascinating physical process called dynamical friction. As more massive objects move steadily through a vast sea of smaller objects, they experience a kind of invisible drag that gently slows them down and causes them to slowly spiral inward toward the core. IC 1101 sits silently at the very bottom of this immense gravitational well, resting exactly at the densest, most crowded part of the cluster, where galaxies are packed most tightly together. This prime location is absolutely not a cosmic coincidence. IC 1101 grew so impossibly large precisely because it was situated in this privileged central position. As other smaller galaxies inevitably spiraled toward the dense cluster center over the eons, they eventually encountered IIC 1101 and were quietly, inevitably absorbed. The exact same relentless physical process that initially brought IC 1101 to the center of the cluster also continuously brought it a constant, steady supply of galactic victims to consume. The incredibly hot gas that completely fills the cluster also plays a profoundly important role in IC 1101's slow evolution. This invisible sea of gas, which astronomers call the intra-cluster medium, is incredibly sparse by any normal earthly standards. If you could somehow manage to scoop up a cubic meter of it, you would find only a few lonely atoms drifting in the space. But because there is simply so much of it spread over millions of light years of space, it adds up to an absolutely enormous, staggering amount of invisible mass. This diffuse gas is so incredibly hot that it continuously emits high-energy X-rays, which is exactly how our modern, orbiting astronomers manage to detect it. Powerful X-ray telescopes, like the brilliant Chandra Observatory, have carefully mapped the invisible distribution of this superheated gas in Abell 2029, successfully revealing that it is densely concentrated around IC 1101 at the cluster's absolute center. The glowing gas forms a kind of vast, invisible atmosphere around the giant galaxy, a thin, superheated haze of particles extending millions of light years out into the cold, intergalactic space. The silent presence of this hot gas has profound implications for the giant galaxy's ultimate future. In the normal course of cosmic events, incredibly hot gas can slowly cool down over immense spans of time, gently radiating away its stored thermal energy as invisible X-rays. When this gas cools down enough, it can finally succumb to gravity, falling rapidly into the central galaxy and potentially fueling a vibrant new era of massive star formation. In some other different galaxy clusters, astronomers have actually observed these enormous silent flows of cooling gas, representing hundreds of solar masses worth of material per year, streaming gracefully into the central galaxy. But in the specific case of IC 1101, something mysterious seems to be actively preventing this cooling flow from igniting a new, beautiful burst of star formation. The leading, elegant scientific theory is that the dormant supermassive black hole hiding at IC 1101 center is entirely responsible for this stagnation. When cooling gas begins to fall toward the hungry black hole, some of that matter gets violently heated up and forcibly blown back out into the surrounding cluster by the immense magnetic forces. This complex interaction creates a delicate, eternal feedback loop, where the sleeping black hole actively regulates the galaxy's gas supply, successfully preventing too much cold material from accumulating and forming new stars. We can actually see the physical, silent evidence of this enormous feedback mechanism in our detailed observations of IC 1101 and its surrounding environment. There are massive, empty cavities in the hot gas surrounding the galaxy, vast invisible bubbles that have been forcefully blown outward by ancient, powerful jets erupting from the central black hole. These staggering cavities are millions of light years across, representing enormous, silent voids carefully carved out of the intracluster medium by the unfathomable energy output of the black hole over millions of years. This delicate, balanced feedback mechanism is widely thought to be absolutely crucial for understanding exactly why incredibly massive elliptical galaxies like IC 1101 are no longer actively forming young stars today. Without the supermassive black hole constantly regulating the incoming gas supply, the steady cooling flows would eventually deliver enough raw, cold material to trigger substantial, vibrant star formation across the galaxy. But the dark titan sitting at the core acts precisely like a cosmic thermostat, violently heating up the surrounding gas whenever too much of it starts to cool down, thus successfully keeping the entire galaxy in a kind of permanent, silent energy balance. The complex, quiet interplay between giant galaxies, their dark central black holes, and the vast oceans of hot gas in galaxy clusters is currently one of the most exciting and active areas of research in modern astrophysics. Dedicated scientists are still tirelessly working out the intricate mathematical details of exactly how this feedback mechanism operates, how it uniquely varies from one ancient cluster to another, and what it ultimately means for the long-term, slow evolution of the universe's absolute largest galaxies. Every new piece of data gathered from the dark helps us gently understand the profound balance that governs the cosmos. Let me now take you gently by the hand and guide you through a quiet timeline of IC 1101's epic history, as best as we can carefully reconstruct it from our distant observations and our beautiful theoretical models. This majestic timeline spans billions of years of cosmic time and involves immense physical processes that are incredibly difficult for our terrestrial minds to fully imagine, but truly understanding it helps us deeply appreciate exactly how this quiet, cosmic giant came to be. The beautiful story begins roughly 13 billion years ago, not long after the explosive birth of the Big Bang itself. The young universe at that ancient time was profoundly different from what we can observe today. There were absolutely no magnificent galaxies yet, just vast, silent, expanding clouds of primordial hydrogen and simple helium gas left over from the first few chaotic minutes of cosmic history. These early silent clouds were not perfectly uniform in their density. Some isolated regions were slightly denser than others, and the patient, invisible hand of gravity began to gently pull these denser regions together in the dark. Over the first few 100 million years, these slightly denser regions slowly collapsed to form the very first brilliant stars and the very first primitive infant galaxies. These ancient galaxies were remarkably small, irregular collections of stars, looking nothing like the grand, sweeping spirals we see today. They formed precisely in the densest, most crowded parts of the cosmic web, the vast, invisible network of dark matter filaments and nodes that fundamentally define the large-scale structure of the entire universe, the specific region of space that would eventually, over billions of years, become the sprawling Abell 2029 cluster, was one of these incredibly dense, privileged regions. Many small galaxies formed in that primordial web, and they immediately began interacting with each other in the quiet dark. Mergers happened frequently in the early universe when galaxies were much closer together and the cosmic web was far more compact than it is today. One of those early fragile galaxies, or perhaps more likely a chaotic merger product of several early galaxies, was the ancient ancestor of IC 1101. We do not know exactly what this primordial proto-galaxy looked like, but it was probably a collection of a few billion stars, maybe 100,000 light-years across, with a growing black hole hiding at its center. Over the next several billion years, this proto-galaxy experienced merger after merger. Each time a smaller galaxy wandered too close, gravity captured it and eventually absorbed it. Each violent merger added stars and gas, and each merger fed the central black hole. The galaxy grew larger and larger, and its position at the center of a dense region ensured a steady supply of victims. By about 10 billion years ago, the ancestor of IC 1101 had probably already become a giant elliptical galaxy, having experienced dozens of major mergers. It would have been one of the largest galaxies in its part of the universe even then, though not yet as massive as it is today. The next several billion years saw continued growth, though at a progressively slower pace. The most intense period of galaxy formation was slowly winding down across the entire universe. Star formation rates were declining as galaxies used up their precious gas supplies. Mergers became less frequent as the continuous expansion of the universe carried galaxies farther and farther apart. But IC 1101 was safely resting in a special location. The Abell 2029 cluster had grown and matured, and IC 1101 sat at its heart. Galaxies continued to fall toward the cluster center, drawn by the enormous combined gravity of all the matter there. And when they reached the center, they encountered IC 1101. During this long period, IC 1101 probably experienced another 20 or 30 major mergers, along with countless minor ones. Each merger added to its mass. Each merger stirred up its stars. Each merger fed its already enormous black hole. By about 5 billion years ago, IC 1101 had grown to something remarkably close to its current size. It contained tens of trillions of stars spread across millions of light-years of space. Its black hole had grown to tens of billions of solar masses, and it had essentially run out of easy prey. The galaxies that remained in the cluster were either too far from the center to be captured easily, or were locked in stable orbits that would take many more billions of years to decay. IC 1101 had consumed most of what it could consume. Its days of rapid, violent growth were over. What remains today is exactly what we observe. A dying giant, still enormous, still magnificent, but no longer growing. Its stars are old. Its gas is heavily depleted. Its black hole is relatively quiet, occasionally flaring up when a bit of gas wanders too close, but mostly dormant. IC 1101 has reached something like a steady state, slowly fading as its stars burn out one by one. This history is not unique to IC 1101. Many giant elliptical galaxies at the centers of clusters have similar ancient stories, but IC 1101 represents an extreme case. a galaxy that was in the right place at the right time to grow to truly exceptional proportions. It is not the only giant in the universe, but one of the very largest we have ever found. But the growth cannot continue forever, and the universe itself is changing in ways that will eventually affect every galaxy, including this enormous one. Space itself is expanding, and not just expanding, but actively accelerating in its expansion. This mysterious acceleration is driven by something scientists call dark energy, a profound force that makes up about 68% of the total energy in the universe, but whose fundamental nature we do not understand at all. Let me gently explain dark energy a bit more, because it is one of the most fascinating and puzzling discoveries in all of science. For most of the 20th century, astronomers assumed that the expansion of the universe was gradually slowing down. This made perfect intuitive sense. Everything in the universe is constantly pulling on everything else through the quiet force of gravity. You would logically expect all that gravitational attraction to act like a brake, gradually slowing the massive expansion that began with the Big Bang. But in the year 1998, two independent teams of astronomers made a truly shocking discovery. They were carefully measuring the expansion rate of the universe by observing distant supernovas, using them as standard candles to calculate cosmic distances. What they found was completely unexpected. The universe was not slowing down, it was speeding up. Distant galaxies were moving away from us faster than closer ones, and the overall rate of expansion was accelerating over time. This discovery was so deeply unexpected that the astronomers initially thought they had made a mathematical error. But as more data came in from more supernovas and from other observations, the staggering result held up. Something was physically pushing the universe apart, counteracting gravity and causing space itself to expand at an ever-increasing rate. Scientists named this mysterious force dark energy. Though the name tells us very little about what it actually is, we know that dark energy makes up about 68% of all the energy in the universe. We know that it acts as a kind of anti-gravity, gently pushing space apart. We know that its effects become more important over immense stretches of time as the universe expands and ordinary matter becomes more spread out. But we do not know what dark energy is physically made of, where it comes from, or exactly why it has the strength that it does. It might be an inherent property of empty space itself, something called the cosmological constant that Albert Einstein once proposed, and then famously called his biggest blunder. It might be a new energy field pervading the universe. It might even be a profound sign that our current understanding of gravity is fundamentally incomplete and needs to be revised. What we do know is that dark energy is reshaping the future of the cosmos. As space expands faster and faster, distant objects recede from us at ever-increasing speeds. There is a strict limit to how fast light can travel, but there is absolutely no limit to how fast space itself can expand. Eventually, objects will be carried away from us by the expansion of space faster than their light can travel toward us. When that happens, they will vanish completely behind a cosmic horizon, forever beyond our reach. For C 1101, this means that its long days of growth through galactic cannibalism are numbered. Eventually, there will be no more galaxies left to consume. It will become totally isolated, a lonely giant floating in an ever-emptying universe, watching as one by one the other galaxies fade from view. Let me paint a more contemplative picture of this incredibly distant future. Remember that C 1101 sits safely in the Obel 2029 galaxy cluster, surrounded by hundreds of other galaxies. These galaxies are bound by gravity, orbiting their common center of mass. For now, gravity is strong enough to hold the cluster together against the relentless expansion of space. But in about 100 billion years, the expansion will have accelerated to the point where galaxies outside the local supercluster will start to permanently disappear over the cosmic horizon. From IC 1101's perspective, the night sky will start to empty. One by one, distant clusters will fade from view, their light no longer able to cross the expanding void. The observable universe, which currently contains about 2 trillion galaxies, will shrink and shrink. Within the Abel 2029 cluster, things will naturally unfold differently for a while longer as the greater universe expands. The countless galaxies residing there are close enough to one another and bound tightly enough by their mutual gravitational embrace that they will quietly stay together even as the larger universe empties out around them. Over the next several billion years of cosmic time, these remaining galaxies will continue to gently interact, gracefully merge, and slowly evolve in the dark. IC 1101 might still gently consume a few more galactic victims, growing slightly larger even as the rest of the infinite universe slips away into the silence. But eventually, in the deep sweep of time, even the independent galaxies within the cluster will inextricably merge together into a singular entity. The very same ancient, relentless processes that painstakingly built IC 1101 will continue drawing the remaining galaxies toward the absolute center, where they will be peacefully absorbed into an even larger, combined structure. In the very long run, perhaps in several 100 billion years, all the galaxies in the Abel 2029 cluster might fully merge into a single, enormous galaxy, even larger than IC 1101 is today. By that unimaginably distant time, however, the universe beyond the cluster will be essentially entirely empty. No light from distant objects will be reaching the cluster anymore, as the expansion of space will have carried everything else beyond the visible horizon. The night sky, if any curious observers still existed to look up in wonder, would show only the local stars of the local merged galaxy against a backdrop of absolute, impenetrable blackness. The rest of the cosmos would have slipped safely beyond the horizon, forever unreachable and profoundly unknowable to anyone left behind. This is the deep, quiet isolation that awaits IC 1101 and every other structure in the universe, gently cut off from everything else by the relentless expansion of space. Each island of matter will be left completely alone with itself as the eons roll by in the dark. But even this profound isolation is not the final, ultimate fate of IC 1101. What exactly happens to a massive galaxy in a universe that is slowly, inevitably winding down toward a quiet heat death? The answer to this ancient mystery is as beautifully magnificent as it is deeply melancholy. Over the next 100 trillion years, the trillions of burning stars in IC 1101 will slowly, quietly burn out. The massive hot blue stars went long ago, exploding violently as supernovas or collapsing silently into dark black holes. The middle-sized stars, much like our own beloved sun, will puff up into glowing red giants, shed their outer layers as beautiful, ephemeral nebulas, and then slowly fade away as cold, dense white dwarfs. Even the absolute smallest, longest-lived stars, the gentle red dwarfs that patiently burn their nuclear fuel so slowly they can shine for trillions of years, will eventually exhaust their primordial hydrogen and go completely dark. Let me gently walk through this slow, stellar death in more contemplative detail, because the timescales involved are truly mind-boggling and invite a profound sense of awe and wonder. The most massive stars in IC 1101, the brilliant blue giants and supergiants, live fast and die incredibly young in the cosmic sense. They violently burn through their fuel in just a few million years before exploding as brilliant supernovas. Any blue giants that IC 1101 once possessed burned out billions of years ago. The galaxy today is entirely dominated by older, smaller, much longer-lived stars. The stars, most similar to our Sun, have total lifetimes of about 10 billion years. Our own Sun is roughly halfway through its beautiful life, with about 5 billion years left before it swells into a red giant and eventually becomes a white dwarf. In IC 1101, many Sun-like stars have already quietly completed this process, leaving behind dense white dwarf remnants floating in the silence. Others are still shining bravely, but over the next several billion years, they too will inevitably burn out. But the absolutely most numerous stars in any galaxy are red dwarfs, tiny stars with only a fraction of the Sun's mass. Red dwarfs burn their fuel so incredibly slowly that they can shine peacefully for trillions of years. A red dwarf born at the exact same time as our Sun will still be shining long, long after the Sun has become a cold, dead white dwarf. In IC 1101, with its 100 trillion stars, there are untold, unimaginable numbers of red dwarfs. These tiny, dim stars will be the very last to go out. For trillions of years after the larger stars have died, the gentle red dwarfs will continue to burn, providing the only faint light in an otherwise rapidly darkening galaxy. But even red dwarfs have their absolute limits in the grand sweep of cosmic time. The absolute smallest red dwarfs, with perhaps 8% of the Sun's mass, can burn for up to 10 trillion years. That is about 700 times the current known age of the universe. But eventually, even they will exhaust their hydrogen fuel and fade gently into the eternal darkness. Scientists estimate that the process of star formation in the universe will effectively cease entirely in about 100 trillion years. By that unfathomably distant time, the gas and dust needed to make new stars will have been completely used up or dispersed too thinly to ever collapse again under gravity. No new stars will be born to replace the ones that have died. The beautiful, glowing era of starlight will be completely over. One by one, the 100 trillion stars of IC 1101 will wink out like exhausted candles in a vast empty cathedral. The galaxy will grow dimmer and dimmer over time scales that make the current age of the universe seem like the mere blink of an eye. Where once there was a magnificent blaze of stellar light, there will eventually be absolutely nothing but the cold, dark remnants of dead stars, white dwarfs, neutron stars, and black holes drifting aimlessly through an ever-expanding void. The universe at this specific stage will be a profoundly dark place, but importantly, not an entirely empty one. All those stellar remnants, all those countless white dwarfs, neutron stars, and black holes will still exist in the silence. They will orbit blindly through the merged remnant of what was once IC 1101 and its cluster companions. The galaxy will be a silent ghost of its former self, completely populated by the corpses of stars rather than by living, burning suns. But incredibly, even this is not the end of the long journey. Over even longer timescales, measured in years, with so many zeros that writing them out would fill volumes of pages, even these stellar corpses will inevitably decay. White dwarfs will slowly, patiently cool until they become black dwarfs, objects that no longer emit any light or heat at all. This gentle cooling process takes an almost inconceivable amount of time. A white dwarf cools to near absolute zero only after about 10 to the 15th power years, or about 1,000,000,000,000 years. That is roughly 100,000 times longer than the current age of the universe. Neutron stars might also decay as their fundamental subatomic particles gradually break down in the dark. We are not entirely, absolutely sure about this because it depends heavily on whether protons, the essential building blocks of atomic nuclei, are truly stable or whether they eventually, inevitably decay over deep time. Some advanced theories of particle physics predict that protons should decay with a half-life of around 10 to the 34th power years or even longer. If this is indeed true, then over unfathomably long time spans, even the physical matter that makes up neutron stars, white dwarfs, planets, and absolutely everything else will gradually dissolve into a sea of thin radiation. And the black holes, including that enormous monster resting at the center of IC 1101, will slowly evaporate through a quiet, invisible process called Hawking radiation. The brilliant physicist Stephen Hawking beautifully discovered that black holes are not truly black. They slowly leak particles and radiation over immense time spans, gradually shrinking as they do so. This happens because of delicate quantum mechanical effects near the event horizon. In the strange, microscopic world of quantum physics, particle pairs are constantly popping into existence and then immediately annihilating each other. Near a black hole's event horizon, one member of such a pair can fall into the black hole while the other escapes into space. Over unimaginable eons of time, this process drains energy from the black hole, causing it to slowly shrink in the dark. The rate of Hawking radiation is incredibly slow for large black holes. A black hole with the exact mass of our sun would take about 10 to the 67th power years to completely evaporate. That is a 1 followed by 67 zeros. But the supermassive black hole at the center of IC 1101 is billions of times more massive than the sun, and the time required for it to evaporate is correspondingly incomprehensibly longer. A black hole containing 50 billion solar masses would take something like 10 to the 100th power years to fully evaporate, or maybe even longer. That is a Google years, a 1 followed by 100 zeros. To write out that massive number in full would require more paper than exists on the entire Earth. It is a span of time so vast that absolutely everything we have discussed so far, from the fiery Big Bang to the quiet death of the last stars, is not even a rounding error by comparison. But even this immense, incomprehensible time is not infinite. Eventually, trillions upon trillions upon trillions of years from now, even the supermassive black hole at the heart of IC 1101 will have gently radiated away its last bit of energy and disappeared from the universe in a final, silent burst of Hawking radiation. When that finally happens, there will be absolutely nothing left of IC 1101 at all. No stars, no black holes, no remnants of any kind, just the fundamental particles and thin radiation that once made up a magnificent galaxy spreading out through an ever-expanding, ever-cooling, ever-darkening universe. the largest galaxy we have ever found, will have faithfully followed the same ultimate path as every other structure in the cosmos, peacefully dissolving into the endless night. This specific vision of the deep future might seem incredibly bleak to some, but I find something strangely beautiful and profoundly comforting about it. IC 1101 exists right now in this brief, glowing moment of cosmic history, when stars still shine brilliantly and galaxies still glow against the dark. It has existed for billions of years and will continue to exist for billions more in the grand sweep of cosmic time. The era of stars and galaxies is just a passing phase, a brief, magnificent flowering of complexity between the absolute chaos of the early universe and the cold emptiness of the far future. We are incredibly lucky enough to exist during this beautiful flowering. We are lucky enough to have evolved intelligence, built telescopes, and pointed them at the quiet sky. We are lucky enough to have discovered Galaxy 1101 and to understand, at least in part, what it is and exactly how it came to be. In all the vast ancient history of the universe, stretching from the Big Bang to the final heat death, this moment, right now, is incredibly special. It is the exact moment when the universe has successfully developed the ability to look at itself and experience pure wonder. And what we see when we look at IC 1101 is the grandest scale on which the universe has assembled matter into organized structures. We see billions of years of cosmic history written in stars, revealing the results of countless galactic mergers, countless collisions, and countless acts of gravitational violence that have somehow produced something magnificent. We see a monster, yes, but also a monument to the forces that shape our universe and to the processes that have been building complexity ever since the first atoms formed. Let me bring us back closer to home for a moment. Our own Milky Way is not immune to the forces that shaped IC 1101. We too are participating in the cosmic dance of galactic interaction and merger. Right now, our galaxy is in the process of consuming several smaller galaxies, including the Canis Major Dwarf Galaxy, which is being ripped apart and absorbed into the Milky Way. The Sagittarius Dwarf Galaxy is also being stretched and distorted by our gravitational pull, leaving streams of stars from past victims that can be traced across our sky as ghostly reminders of galaxies that once existed as separate entities. And in the future, an even more dramatic event awaits. The Andromeda Galaxy, our nearest large neighbor, is heading toward us. Scientists have long believed that in about 4 to 5 billion years, the Milky Way and Andromeda would collide and eventually merge into a single larger galaxy, often nicknamed Milkomeda. Recent research has introduced some uncertainty into this prediction. New studies using data from the Gaia spacecraft and Hubble Space Telescope suggest that the collision might not be as certain as we once thought. When scientists account for the gravitational influence of other nearby galaxies, like the Large Magellanic Cloud and the Triangulum Galaxy, the probability of a collision drops significantly, with some simulations now suggesting only about a 50% chance of a merger happening within the next 10 billion years. But whether it happens in 4 billion years, 10 billion years, or not at all, the process itself illustrates the same forces that created IC 1101. Galaxies interact, merge, and consume each other as it is the way of the universe. And even our own quiet corner of the cosmos participates in this cosmic competition. If the merger does happen, the results would be spectacular. At least on cosmic time scales. The collision itself would not be violent in the way you might imagine, because stars are so far apart that the chances of any two stars actually hitting each other are essentially zero. But the gravitational effects would be dramatic. The spiral structures of both galaxies would be destroyed. Gas clouds would be compressed, triggering enormous bursts of star formation, and the two supermassive black holes at the centers of each galaxy would eventually find each other and merge, releasing gravitational waves that would ripple across the universe. Over billions of years, the chaos would settle down. What was once the Milky Way and what was once Andromeda would blend together into a single large elliptical galaxy, much like IC 1101, but much smaller. Future astronomers, if any exist, might look back at old records and marvel that their smooth, featureless home galaxy was once two beautiful spirals dancing through the void. By that time, of course, Earth will be long gone. Our sun is expected to expand into a red giant in about 5 billion years, swelling to a size that would engulf our planet. Whether humanity survives until then, whether we spread to other star systems, whether intelligence of any kind persists in the universe, these are questions we cannot answer. But the story of IC 1101 reminds us that the universe operates on time scales that dwarf individual lives, individual civilizations, even individual planets. I want to return now to the question of what IC 1101 tells us about our place in the universe. When you look up at the night sky, you might feel small or feel insignificant in the face of such vastness. But I think the existence of IC 1101 actually tells us something hopeful about our situation. First, consider that we can know about IC 1101 at all, a galaxy more than 1 billion light-years away, containing 100 trillion stars, and we have figured out how big it is, how it formed, and what lies at its center. That is remarkable. Human beings living on a small, rocky planet orbiting an ordinary star in an unremarkable part of an average spiral galaxy have somehow developed the ability to understand objects so far away that their light left before complex life existed on Earth. This ability to understand is not nothing. In a universe of mindless matter and energy, of particles bouncing around according to physical laws, somehow here on Earth, consciousness has emerged, minds that can wonder, question, investigate, and learn. Whatever else we are the part of the universe that has woken up and started asking questions about itself. Second, consider that IC 1101, for all its enormity, is made of the same stuff we are. The stars in IC 1101 are fusion reactors just like our sun. They burn hydrogen into helium and heavier elements just like stars do everywhere. The atoms in those distant stars are the same kinds of atoms that make up our bodies: carbon, oxygen, nitrogen, iron. All of them were forged in the hearts of stars somewhere in the universe. Just as the atoms in our bodies were forged in stars that exploded before our sun was born, there is a continuity here, a connection between us and everything else in the cosmos. We are not separate from the universe. We are part of it. The same processes that built IC 1101 built us. The same atoms that shine in distant galaxies shine in our eyes. We are not observers of the universe from outside. We are the universe observing itself from within. Third, consider what it means that galaxies like IC 1101 can exist at all. The universe did not have to be this way. If the fundamental constants of physics were slightly different, if gravity were a little stronger, or the nuclear forces a little weaker, stars and galaxies might never have formed. The universe might have collapsed back on itself moments after the Big Bang, or expanded so fast that matter never clumped together. Instead, we live in a universe where physical laws allow for the formation of stars, planets, galaxies, life, and mind. IC 1101 is a testament to what is possible in such a universe. It is proof that matter and energy, following simple physical rules over billions of years, can organize itself into structures of staggering complexity and beauty. If the universe can produce IC 1101, what else might it be capable of? What other wonders exist out there that we have not yet discovered? This brings me to the final point I want to make about IC 1101 and about our quest to understand the universe. Every discovery we make, every galaxy we study, every black hole we observe expands our sense of what is possible. A few centuries ago, people thought Earth was the center of everything. Then we learned that we orbit the sun. Then we learned that the sun is one star among hundreds of billions in our galaxy. Then we learned that our galaxy is one of trillions. Each step has made us smaller in some sense, but it has also made the universe grander, more interesting, and more worthy of awe. IC 1101 is another step in that journey. It shows us that the universe can build things far larger than we ever imagined. It challenges us to keep asking questions, to keep looking further, to keep pushing the boundaries of what we know. And it reminds us that, for all our insignificance on cosmic scales, we are the ones doing the asking, doing the looking, and doing the pushing. In the face of IC 1101's enormity, we can feel small, or we can feel wonder. I choose wonder. As we wrap up this exploration of the biggest galaxy ever discovered, I want to leave you with one final image. Imagine yourself floating in space somewhere near the edge of IC 1101. Around you, in every direction, stars stretch out toward infinity. Not hundreds, not thousands, not millions, but trillions of stars. Each one is a sun. Each one might have planets. Each one has been shining for billions of years. You cannot see the center of the galaxy from here. It is too far away, hidden behind countless curtains of stars. You cannot see the edge either. The galaxy fades gradually into the darkness of intergalactic space with no clear boundary. You are lost in a sea of light, adrift in a structure so vast that crossing it would take millions of times longer than human civilization has existed. And yet, from a small rocky planet more than 1 billion light-years away, beings who live for less than a cosmic instant have figured out that this place exists. They have measured its size, counted its stars, and found the black hole at its heart. They have traced its history back billions of years and projected its future trillions of years hence. They have placed it in the context of an entire universe and marveled at its grandeur. That is perhaps the most amazing thing of all. Not that IC 1101 exists, but that we know it does. The atoms in your body were forged in stars. The carbon that makes up your muscles, the oxygen you breathe, the iron in your blood, all of these elements were created in the nuclear furnaces at the cores of stars that lived and died before our sun was born. When those ancient stars exploded as supernovas, they scattered their elemental riches across space. Eventually, some of those atoms found their way into a cloud of gas and dust that collapsed to form our solar system. They became the Earth. And then, after billions of years of evolution, they became you. You are made of star stuff. This is not poetry. It is chemistry. The very same processes that light up ICC 1101's 100 trillion stars also created the matter from which you are assembled. There is a direct physical connection between you and those distant fires. In a very real sense, when you contemplate I see 1101, you are star stuff contemplating more star stuff. The universe is looking at itself, trying to understand what it is and how it came to be. We are not separate from the cosmos we study. We are part of it, and our curiosity is the cosmos being curious about itself. I see 1101 will never know that we have discovered it. Galaxies do not have minds or experiences, but we know. And in knowing, we complete a circuit that connects human consciousness to cosmic grandeur. We are tiny, yes. We are brief, yes. But in the brief moment of our existence, we can reach out across 1 billion light years and touch the largest galaxy ever discovered. That reach is our glory. When you next look up at the night sky, remember I see 1101. You cannot see it with your eyes. It is far too distant and too faint for human vision. But it is there, in the direction of the constellation Virgo, shining with the light of 100 trillion stars. It has been there for billions of years, and it will remain there for billions more. Long after our sun has burned out, long after Earth has been consumed by an expanding red giant, I see 1101 will still be there, slowly fading into the cosmic night, but not yet gone. We are part of a universe that contains such wonders. We are made of the same stuff as I see 1101 stars, formed by the same processes, governed by the same laws of physics. In studying that distant giant, we learn about ourselves and our place in the grand story of cosmic evolution. The biggest galaxy we have ever discovered is bigger than your imagination. But the fact that you can imagine it at all, that you can hold in your mind a picture of 100 trillion stars spread across millions of light years, that you can wonder about its past, future, and inhabitants, that is perhaps the most amazing thing of all. Thank you for joining me on this journey through the biggest galaxy ever discovered. If this video helped you see the universe in a new way, please consider leaving a comment, letting us know what you think about our place in a cosmos that contains such wonders. And if you want to keep exploring the mysteries of the universe with us, do not forget to like this video and subscribe to the channel. Until next time, keep looking up and keep wondering.